So, good morning everybody. Myself Acharya Vishvendra, and today I'm going to discuss a worksheet on angular impulse. So, let's begin with the worksheet. Here is the worksheet. So, here is the worksheet on angular impulse. So, the first question is dimensions of angular impulse. So, angular impulse is change in angular momentum. So, its dimension is same as that of angular momentum, which are ml2 t minus 1. Next is SI unit of angular impulse. It is kg meter square second minus 1. CGS unit grams centimeter square second minus 1. SI upon CGS unit ratio, the ratio comes out to be 10 is to power 7. Next is what is angular impulse? So it is integration of torque dt and also equal to change in angular momentum. Next is torque is t square minus 3t plus 2. You need to find torque at t is equal to 0. So substitute t is equal to 0 over here, we get torque as 2. Similarly at t is equal to 1, we get torque as 0. And t is equal to 2, we again get torque is equal to 0. Next question is torque t graph. So since this is a quadratic equation, so graph will be a parabola and 1 and 2 are the roots of the parabola. So graph will be like this, and at t is equal to 0, torque is equal to 2. So this graph can be drawn like this. Now we need to find uh, angular impulse during 0 to t. So angular impulse is integration of torque dt. So which is t square minus 3t plus 2 into dt. After solving we get this. Next is angular impulse from 0 to 4 second. So substitute t is equal to 4, we get 70 by 3. Next is a question. There is a rod of length L. An impulse is applied at a distance of x. Then we need to find the angular impulse. So angular impulse is equal to linear impulse into the perpendicular distance. So it will be ix. Next is jx graph. So jx graph will be a straight line as shown here. Next is jmax. So jmax is I into x max, which is I into L. Next is we are being given a sphere on which impulse is applied at a distance of x from the center of mass. We need to find angular impulse about c. So we can see that perpendicular distance is x. So angular impulse about c is mv into x. Next is velocity of center of mass. So masses are equal, so velocity of center of mass will be v. Next is angular impulse. It is change in angular momentum, which is mvx. So suppose the sphere rotates about the center of mass with angular speed omega. So mvx will be equal to I omega. So from here omega comes out to be mvx upon I. Next is torque about p. So torque is change in angular momentum per unit time, which is mvx by delta t. Next question here is dimensional formula of moment of inertia. It is m1 l2 t0. Next is torque about p. It is m1 l2 t minus 2. So you have seen that this is a basic level worksheet on angular impulse, and its purpose is to make sure that students actually decode the pattern of preparation for JEE and NEET. Because the first thing that you need to develop is a neural pattern which is aligned along with problem solving skills. So these worksheets are the very basic worksheets in which you can learn gradually and learn the basic concepts, basic terms, and learn how to apply them so that you can move on to the next level. So these worksheets are the basic worksheets needed to help the students who are just about to prepare or have just started preparing and are facing difficulty in their physics classes. So these are the optimization tools for making sure that you have sharp problem solving skills. Thank you and have a nice day.